in a tournament has the highest average after 5 games, scores 210, 225, 254, 231, and 280. In order to maintain this exact average, what must Marlon score for the 6th game be? How'd you get it? Add them all up, divide by 5, which gives you the average score. Everyone agree? And the average score is 240. Is that right? Well, wouldn't he have to score another 240 to keep the same average? So, okay. Any questions about that?
That is so easy. What do you got?
The graph of negative 5x squared plus 9 passes through the point 1, 2a in the xy coordinate plane. What is the value of a? Well, let's find out what it goes through at 1. Could I plug in 1 and find out the y value? Do that. Do we get 4? So what's a have to be? 2a has to be 4. So I plugged in 1 into the that's the x value. So I want to know what's the y value. It's 4. Well, 2a must have to equal 4. Okay. The equation x squared plus nx plus n equals 0 and n are integers. The only possible value for x is negative 3. What is the value of m? This is a factoring solving question in reverse. If negative 3 is the solution to a quadratic equation, would you the only solution? Wouldn't you agree it would have to factor to be this? If negative 3 is the only solution to a quadratic, so we're having to backwards think. This is supposed to be one of the hardest problems of this ACT, right? It's number 59. It's when they start getting really difficult. Is that really that difficult? Not really. Now I want to know the value of m. I'll FOIL this out. X squared. It is. What makes this equal?
Oh, it's not negative 3.
So it would have to be x plus 3 to get a negative 3 as an answer. Everyone agree that's what that FOILs to be? So m would have to be 6. 3 plus 3 is 6. M. So that was actually a factoring question. In a weird sort of way, it was a factoring question. What is a least common multiple? The smallest number that they all go into, right? Okay. So let's just start going through them. Does 70 go to 60? Does 70 or 50 go to 180? Does 50 go into 210? Try it. Do 210 divided by 50. Okay, 2100.
Yes.
All three?
Yes.
So I remember I want the least one, so that's where I'm going to stop. Any questions about that? Okay, today we're going to learn about variation. This is the last new topic in this chapter. There are 2 types of variation. There's unit variation and inverse variation. Neither one of these things are difficult, but the ACT expects that you know those words. Have y'all ever heard that on the ACT before? Y varies directly with X, or Y varies inversely with X. As long as you know what that means, they're pretty easy problems. If you don't know what that means, they're very difficult. So that's what we're going to learn about today is direct and inverse variation. One variable varies directly with another. It's called direct variation. What that means is as one variable increases, so does the other. If y varies directly with x, then this is the equation we're going to set up. Y equals x times some constant k. If y varies directly with x, then y equals some constant times the variable x. So we're going to look at how we can use that to solve some direct variation problems. So as soon as I read that in a word problem in a sentence, y varies directly with x, I'm going to write y equals constant times x, or k is a constant. I don't know what k is. In fact, that's part of the problem, is to find k. It tells me that y equals 27 when x equals 6. If I know that, can I find k? Y equals 27 and x equals 6. Can I find k? So I'm going to put 27 in for y and 6 in for x. Divide both sides by 6. So k would be 27 over 6. Reduces a little bit to 9 over. You can also write 4.5. Either way. Any questions about how to find k? Does that make sense?
How did you notice that shit?
Oh, it doesn't matter. Sorry. I didn't mean to. You could leave it the other way. Sorry. Multiplication, Kyle, is commutative, so it doesn't matter what. But either way. Now, am I finished with the question? No, it asks me to find y when x is 10. So first I'm just going to rewrite my direct variation equation. I now know that k is 9 over 2. So this is my equation. You can see kind of why we put it in this chapter. That's a linear equation, so it's something we've dealt with before. And then what's y when x is 10? Good. 9 over 2 times 10. And so I get 5 times 9, which is 90 divided by 2 either way. Any questions about that? There were actually 3 answers to this problem. If I were grading this on a test, I would be looking for k, I would be looking for the rewrite of the equation, and I would be looking for the three answers in one. On an ACT, sometimes they'll ask for k, sometimes they'll skip straight to asking for a value, so I want you to be able to find all of those. Is this a real hard question? But it's really hard if you don't know what very directly means. So it's, again, just another ACT skill that we can check off the list that we now know how to do. If y varies directly as x, so y equals 30 when x equals 4, find k. And then find x when y is 27. So again, we have a direct variation, so the first thing I'm going to do is write the equation. Y is 30 when x is 4. Divide by 4. Divide both sides by 4. So I get 30 over 4 or 15 over 2. Okay. Again, if you write that as 7.5, will that get to you? Absolutely. I don't care whether you use fractions or decimals. Either way is wonderful. question is a little, not huge, but slightly tougher. Jacob's saving. Slightly tougher than the other one. Why? Not a lot tougher. Slightly tougher. I can't just multiply by 270 because 270 is the y value. So I found k, found my equation. So I'm going to write 270 equals 15 over 2 times x. And then how will I get x by itself? Divide by 15 over 2, or you could multiply by 2 over 15 either way. So divide by 15 over 2 or by 7 and a half. And what do you get? 36. So that's the basics of direct variation. The third one is a tougher direct variation. Horrible, but a little bit tougher. It still says y varies directly, but this time it doesn't say y varies directly with x. What does it say y varies directly with? The cube of x. So how will my equation be different? X will be cubed. So y varies directly with x cubed. So the varying directly part is that whenever it's varying directly with, it's multiplied by a constant. So the equation's slightly different. It is negative 67. Any questions so far about the setup before I keep going? Any questions about how I set it up? Y varies directly as the cube of x. Makes sense? Okay. And so now I'm going to plug in the 3 for x and the negative 67.5 for y. 3 cubed is 27. Someone with a calculator told me what negative 67.5 divided by 27 is. Negative 2.5. So y equals negative 2.5x cubed. Any questions so far? Find x when y is negative 540. How do I do that? Negative 540 for y. Divide by negative 2.5. That is negative 540 divided by negative 2.5. 916. 256. That's better. Because I believe that is a perfect cube, isn't it? What's the cube root of 216? Math. But now you could also use a 1/3 power for now math. 6. Yes. What is the cube root of 6? 6. Any questions about that one? Yep. If y varies directly as the square of x, okay, how is that one going to be set up? Y equals k times x squared. Does everyone kind of get the gist of this? K times whatever you're varying directly with. Y equals 20 when x is 2. Am I going too fast? A little bit, yes, I can. Okay, so 5 is k, so y equals 5 times x squared. And then find y when x is 6, so we'll just plug in the 6 for x. 36 times 5, 180. Okay, so that's how direct variation works. We're also going to learn inverse variation. Very similar, except it just has a different original equation. The work will be similar if you start with a different original equation. Inverse variation means that as y increases, x decreases. It's inverse relationship. So if we have an inverse variation, y will equal k times k divided by x instead of k times x. So write that down. Y will equal k divided by x. You see why we call this inverse variation? So if you read direct variation, you do y equals k times whatever you're very directly with. For inverse variation, you do y equals k divided by whatever you're varied with. You will need to memorize that setup for ACT and your tests. These are the only two things we are learning today: direct variation and inverse variation. It will. And it's on the review. I just gave you the review really early because some people like to have it over a weekend. So I gave you that. Tests will be Monday and Tuesday. The review is due Thursday. So tonight you have homework, but Wednesday night and Thursday night, or Tuesday night and Wednesday night, your homework will be the review. Monday and Tuesday.
Where it's like this review, okay?
That is the open response part, and then there's also a multiple choice part.
That's right. Yeah. This is one.
Thursday. The review is due on Thursday. Tomorrow we are going to mastery exam. As soon as you're finished with the mastery exam, you can work on the review. That's tomorrow, and then you can do it tomorrow for homework. Wednesday in class you'll have review work time, and then Wednesday night you can work on it. So you got some time. I'm not making it do without getting you out there. And then Thursday it will be the review. Remember, you need to take the test early. Remember? If you wait until after the play, you will forget. So you need to take it. Now you can just take both parts Monday. That's fine. But
Or can I mistake one of them? And then another one's the next day?
you won't be in here on Tuesday. That's what we're taking. We're taking it Monday, Tuesday. You probably won't be in here on Tuesday.
I mean,
Yeah, you can take one part in class on Monday and one part after school on Monday. I think that would be a great way to do it. Because then you won't really be stressing or anything. Yeah, you can come and set that. And again, I'm not telling you to take it early, but in your best interests, if you do the play for 4 days and don't think about college algebra for 4 days, and then come back and try to take the same try that test I call it every day. Friday. No. Okay. use indirect and direct instead of inverse and direct. So you might want to write in your notes inverse or indirect. All my stuff says inverse because your textbook uses the word inverse, but I have seen that the ACT uses indirect variation for inverse variation. So if you see that, it's the same thing as inverse variation. Okay. So it says y is 21 and x is 15. How do you solve for k? Multiply by 15. Does everyone agree? To undo division, you multiply. So 21 times 15, that's a big number. What is it? 315. And so my equation is y equals 315 divided by x. Find y when find x when y is 12. How will I solve that? I could cross multiply. Y'all like cross multiplying? Call that 12 over 1. Everyone familiar with cross multiplication? When you have an equals and two fractions, you can cross multiply. So I get 12x equals 315. Divide by 12. So x is, calculator, 26.25. Any questions about that? Divide by what? Yes. Just be careful. If you did 12 divided by 315, you'd be wrong. So you have to know that you're but if you do it correctly. Okay. Do you care if I skip number 2? It's similar to the one we just worked. I'm going to go on to one that's a little more complicated. Why is this third one a little bit more complicated? It has squares. Not that it's horrible, but it's a little bit, it's not exactly the same. Y varies inversely as the square of x. What is my equation set up? Very good. Any questions so far? Y is 8 when x is 3. Am I going too fast? Y is 8 when x is 3. So what would k be? 72. How'd you get that? Multiply. Remember, when you're undoing division, we're going to multiply both sides by 9 to get rid of the 9s. Good so far? Nice. Good question. So I get y equals 72 over x squared. Find x when y is 18. If they're asking you to find y when you have x, indirect variation is really easy. Just plug in the x and divide. And so you notice I picked examples that were a little tougher. That doesn't mean all your homework will be the tougher ones. I just figured you would rather see me work the tougher ones than the easy ones. So find x when y is 18. Again, cross multiplication would be a great plan here. 18x squared equals 72. What is 72 divided by 18? 1/4. I think it's 4. You did. Yes. And you see why it would be this way. So I get x squared equals 4. And so what's x? And? Y2 and -2. Anytime you take a square root, you get the plus or the minus. Any questions about that one? questions so that anything that did come up on ACT you're covered. If y varies inversely as the cube of x, that's not what I said that one. Y equals, let's go set that first. Okay, over x cubes, everyone see how I got that? Varies inversely with the cube. Okay, x is 4, y is 25. Over cube is 64. Even at 64 times 25, we're just gonna say that's why it's 1600. And so y equals 1600 over x cubed. 12.8 is the y value. 5.8x cubed equals 1600. What is 1600 divided by 12.8? 125 even? That's a 5. The cube root of 125 is 5. With a cube root, do I need a plus or minus on a cube root? Only on a square root or an even root. Any questions about that one?